All right, this is our last video for chapter 7, and we're going to be talking about molecular formulas. So the molecular formula of a compound can be found by determining the number of empirical formula units in the molecule. So remember, those empirical formula units are the smallest ratio of whole numbers, but it may not be its molecular formula. So for example, if the empirical formula of a compound is CH2, this is something we saw in the last video, its molecular formula could be CH2, C2H4, C3H3, etc. We're just using that empirical formula as kind of our template or our building block, and we're multiplying the subscripts in that to give us the molecular formula. Okay, so how do we find the molecular formula of a compound? Well, first we need to determine its empirical formula. And then we want to calculate the molar mass of the empirical formula unit. And of course, we determine the molar mass of the compound that we have, which will be given in the problems you'll be doing. And then divide the molar mass of the compound by the molar mass of the empirical formula unit to get this thing called N, okay? Which is the number of empirical formula units per molecule. And then we can use that information to write the molecular formula. So as with all things that I read like this, it may not make a lot of sense until we do some examples together. So let's do that. So what is the molecular formula of a compound with an empirical formula of C5H10O and a molar mass of 258 grams per mole? Okay, so we're given the empirical formula. So that's the first step. Now we need to calculate the molar mass of the empirical formula unit. And we're given the molar mass of the compound, right? So we just have to do step 2 here for now. Okay, so similar, I'm going to write down what I have, okay, and how much of each I have. So 5 of those, 10 of those, 1 of those. Get their masses off the periodic table. We're getting plenty of practice doing this now. Okay, when I do all of that and add it up, I got 86.15 grams per mole. This is for the empirical formula unit. This is for C5H10O. Okay. So now what's our next step? Well, I have the molar mass of the empirical formula unit. I have listed the molar mass of the compound. So now I'm going to divide the molar mass of the compound by the molar mass of the empirical formula unit to get this guy called N. So I'm going to divide the molar mass of the compound, 258 grams. I'm going to divide that per mole, divided by 86.15 grams per mole. Okay. And when I do that, I get approximately 3, okay, which is equal to N. So now I'm going to use that to find out how many empirical formula units of each I have. Well, I have 3 empirical formula units. So it's going to be like 3 times C5H10O. In other words, you can write it out like this maybe. You could say it's going to be C, this is going to be the molecular formulas structure. 5 times 3, H, 10 times 3, O. Remember, there's a 1 there, times 3. So the molecular formula, okay, is going to be C15H30O3. Okay, that's the molecular formula. Okay, so that's how we're going to do these problems. Again, you find the mass, the molar mass of the empirical formula unit, and you divide that by the molar mass of the compound. You get this guy called N, which tells us how many empirical formula building blocks we have, and then we multiply that to get together to get the molecular formula. Okay, so let's do an example here where we're not given the empirical formula. So a compound is found to contain 31.42% sulfur, 31.35% oxygen, and 37.23% fluorine by mass. What is the empirical formula for this compound? And then it gives us the molar mass for this compound is 102.1 grams per mole. What is the molecular formula for this compound? So again, why don't you pause the video and try to do this on your own. Find the empirical formula using the steps we learned in the last video, and then find the molecular formula using the steps we learned in this video. Okay, so again, this is by mass, so we can assume that all of these are just grams. So what we're going to do, convert grams to moles. Okay, 32.06 grams sulfur, 1 mole sulfur. So we get the molar mass off the periodic table. Okay. It's going to be about 1. Okay. Two. All right, so I'm just writing these down a little bit faster. Two. You divide everything by the lowest number, right, to get the empirical formula, which is just 1. Divide everything by 1. So that means the empirical formula is going to be SO2F2. Okay, so that's the empirical formula. So now that we have the empirical formula, okay, we want to find the molecular formula. So to do that, we need to find the molar mass of the empirical formula unit. Okay, so kind of putting that over here. So we have sulfur, we have one of those at 32.06. Oxygen, we have 2 of those at 16. Fluorine, we have 2 of those at 19.99. Okay, add all that together, I get 102.06 approximately grams per mole. And if you look at it now, right, we take the molar mass of the formula unit, 1.2.1, divide by what we just got, which is basically the same thing. That's approximately equal to 1, which is equal to n. So in this case, the molecular formula unit is the empirical formula unit. N is just equal to 1, right? So I'll just write it out here. 1 times the empirical formula unit, which is just equal to SO2F2. So this is the molecular formula, okay, for the compound. So hopefully that made sense. That's actually it for chapter 7. Again, please do all the homework. It'll help you out quite a bit in this chapter, and feel free to reach out to me if you have any questions. So I'll see you next time, I believe in chapter 8.